This video is on halohydrin formation. When reacting an alkene with a halogen, if instead of inert DCM or chloroform, a nucleophilic solvent such as water or alcohol is used, the solvent may act as a nucleophile to give you a different product. For example, if we take this cyclohexene and react it with chlorine in water, we actually form this halohydrin product. As the solvent is always in high concentration, it is more likely to act as the nucleophile once the carbocation or the halonium ion is formed to yield you the expected halohydrin product. As the halonium ion is partially positively charged and relatively unstable, and it resembles an epoxide, the solvent will add to the more substituted side, just like an epoxide would have opened under acidic conditions. Halohydrins are versatile molecules as they have both a nucleophilic functional group, the alcohol, and a good leaving group, the halide. Also, as the functional groups are anti to each other, these molecules are literally primed to form epoxides. For example, if we mix this alkene with chlorine and water, we'll form this halohydrin, at which point if we add a base, we will deprotonate the alcohol, which will then do an intramolecular substitution to form an epoxide. This by far is not the most effective way of making epoxides, but it does work. But anyway, back to the halohydrins. You have a go at forming them. What are the products of the following reactions? You may pause now. And here are the answers.